over here, we have a triangle. This is actually a right triangle because this corner here is a right angle. And just some basics to get covered. When we have a capital letter, we're talking about an angle, and the lowercase letter is the side. And ideally, the angle and the side are opposite. Meaning if this is angle A, then this down here is side A. We want them opposite each other because that way it's clear. You know, if we said it was the angle next to it, the side and the angle touched each other, then this could be side A or this could be side A. We don't want that, so the angle and the side are opposite each other. And the way that we say that is the word subtends. So angle A is subtending side A, which goes from C to B. In a right triangle, we typically have angle C be the right angle, which makes side C the hypotenuse. And we all wish we were high on hypotenuse, right? Okay.
Hey. See, the longest one.
I wish I were high on hypotenuse.
One of the three sides.
I wish I was high on hypotenuse.
Side A and B are the legs. In right triangles, you have a hypotenuse and you have legs. So there's three basic trig ratios. There's sine, which we abbreviate sin, but don't ever call it sin. That is sine. Then we use this symbol theta. This theta means you have an angle. It's a variable. We could just as easily call it sine of x, but we like to use this theta, which is a Greek letter, to say you're talking about an angle. Whenever you have a theta, you know you're dealing with an angle. Sine is a ratio. It's the ratio of the opposite side over the hypotenuse side. So all of these sine, cosine, tangent ratios you're going to see today only apply to right triangles. Don't try to apply them to non-right triangles. We'll learn how to do things like that later. Don't call this cos, call it cosine. The cosine is the adjacent side divided by the hypotenuse. It's a ratio, two compared values being divided. And then tangent, don't ever call this tan, please call it tangent. The tangent of theta is the opposite over the adjacent. The thing that can be kind of tricky about this is that the terms opposite and adjacent are relative, meaning they change based on what you're talking about. So if I wanted to find the sine of angle A over here, well then if this is my theta, if this is angle A, sine of theta, then this side is the opposite. So the sine of angle theta would be side A over side C, because this is the hypotenuse. And the cosine of angle theta, if it's A, the cosine of A, well this is the adjacent side to this angle. So adjacent means it's the side touching the angle, but not the hypotenuse. The side that touches the angle but isn't the hypotenuse. So the cosine of angle A is side B over C. But these things change if I have a different angle. So now if I do B, well the sine of B is still opposite over adjacent, but opposite is now this. So the sine of B is B over C, whereas the sine of A was A over C. So whichever side is opposite or adjacent depends on which angle you're talking about. Sine of A, here's the opposite. Sine of B, here's the opposite. So you have to be aware of that level of relativity. Before we go on, I want to talk about what trig ratios really are. My guess is that you've used these before, so I'm not going to go into great detail about like how sine is opposite over adjacent. I want to talk about what's happening though, like where these come from and why they're useful. So I'm going to make a triangle, and this triangle is going to be have a height of 2 and a length of 4, width of 4 really. No, this just isn't quite right. It just popped off there, so I'm going to try that again. Please notice how what I have here is two number lines. A number line that's really the x-axis, and a number line that is really the y-axis. And that gives you a grid. I didn't draw the grid here, but these measurements are giving me like a coordinate plane with the x-y axis. Two number lines make up that plane. Well, this is a 2x4 shape. Let's make the inside of it white. Yeah, I'll keep it black. This will work. This is 2x4. I'm going to make another. So we can solve right triangles, only right triangles, very simply now with sine, cosine, tangent, inverse sine, inverse cosine, inverse tangent, and the Pythagorean theorem. Trig functions allow us to find ratios of two sides. Inverse trig functions let us find angle measures given two sides. Reciprocal trig functions are literally just trig functions flipped over. And then 30, 60, 90s are super important. We'll talk about them more later. Whew, we did it.
Trig day one.